Hello, everyone. Can you hear me? Yes, okay. And you can see my screen, right? Okay, yeah. I understand you were too busy with the assignment, but at least you had some time off from the lecture. You didn't have to listen to me for 2 long hours, at least for a week. Okay, so today we'll have a look on transaction, but before that, this is the analysis of the quiz 1. The marks are already released. Okay, during the tutorial session, if you have any question, feel free to ask your tutor, okay, regarding your mark or regarding any of the questions that you have. It looks good. This is consistent with previous semester's mark as well. Okay, around 10% student got more than 80 in the quiz. Some students are in this section. Hopefully that will increase in the next quiz. The average score was 60%, which is consistent with previous semesters. So I had a look on the previous semester and I found that in last 2 semesters, the average was 60.5 in last 2 semesters. And this is consistent with that one. Normally we see good marks or better marks in quiz 2 than quiz 1. Mostly because this is the first time you are taking the quiz. But yeah, if you have any concern, talk with your tutor because they have marked your submission during the tutorial session, or you can simply send them an email. Okay. First of all, an acknowledgement of the country. I would like to acknowledge the traditional owners of Australia and recognize their continuing connection to land, water, and culture. I am currently on the land of the Burra-Matagal people and pay my respect to their elder, past, present, and emerging. I further acknowledge the traditional owners of the country on which you are on and pay respect to their elder, past, present, and future. Like I said, today we'll learn about transaction. So in a transaction, what does transaction means and what sort of properties we need to fulfill when we are running any transactions. So there are 4 properties that we'll have a look today. First one is atomicity. We are familiar with that term. Next one is consistency, then isolation, and finally durability. So we'll have a look on all of these 4 today, why these properties are needed and how we need to make sure that these properties hold. So first of all, what does transaction means? So we have talked about transaction in our first lecture. If you remember, I have shown you this picture. There I tried to explain the same thing that I'm trying to explain now. Let's say we are trying to transfer $100 from account A to account B. So if we are trying to transfer the money from one account to another, what do we have to do? We have to withdraw that amount from account A and then deposit that one into account B, right? So these 2 things we have to do. Let's assume that we have successfully withdrawn the money from account A. But when we are at account B trying to deposit that money, at that time system fails. For some reason, the system crashes, network issues, for some reason system fails. That simply means that we are not able to deposit that money in account B. After some time, system recovers. But at that time, when he calculated everything, you will see that the total money in these 2 accounts does not match, right? Because we are able to withdraw $100 from account A, but we did not deposit that one in account B. So we are $100 short. Hopefully that thing is making sense. So what can we do in this case? First thing we might think that what should we do in this case so that this sort of situation does not arise? So that's what we are going to learn today. Okay. So first thing, so if I want to transfer the money, we need to make sure that if I withdraw the money, I must have to deposit that one into another account. right? So that is what transfer means. So I have to do these two things, withdraw and deposit. If both of them are there, then everything is fine. If one is there, the other one is not, then something is wrong, right? So now we can see that we have to perform more than one task. So that is what transaction means. Okay. So we are going to write something like this: begin, withdraw $100 from account A, and then deposit $100 into account B, and then commit. So now we can see that instead of only one query, now we have two queries in here. Okay. So withdraw, deposit, that simply means we will write queries for them, like update account, something like that. Okay, so now we have a group of statements instead of only one statement. So when we have a group of statement, that group of statement is known as a transaction. Okay. So to perform some task, now we understand that we probably have to execute a program. Okay, so that program might be consist of more than one SQL queries. Okay, so a collection of one or more operation on one or more databases, which reflects a discrete unit of work. We want to perform some work, we want to transfer the money, but for that we have to perform a collection of work. In this case, we have to perform two tasks, right? So that is what transaction is. So in a transaction, we will have a group of statements that we have to execute all of the statement in the transaction. Whenever we are writing a transaction, a group of statement together, okay, so we need to make sure that these properties holds. This is known as asset property. A means atomicity, C means consistency, I means isolation, and D means durability. So we need to make sure that in a transaction, all of these properties hold. If it does not, then we will say that transaction is invalid. So these are the four properties: atomic, consistent, isolated, and durable. What does they mean? Atomicity, we are familiar with that one. So atomicity simply means the transaction is either performed entirely or not performed at all. Either the whole thing is being done or you cannot do anything, right? You cannot only withdraw some money but not deposit that money. The database will be in inconsistent state. So that is what atomicity means. Either you do 100% or 0% at all. Okay, so if everything is fine, then good. If something is done but something is not, you need to return back to 0%. Okay, so either 0% or 100% for atomic. Consistency simply means a correct execution of transaction must take database from one consistent state to another. What does consistent state means? That the data we have in the database, they are fulfilling all the requirements that we have. Requirements simply means all the ICs. So if you remember, IC means integrity constraints, right? So all the integrity constraints that we have in a database. So we need to make sure that after we make some changes using a transaction, all of those conditions are still satisfied, right? So that is what consistency means. Isolation is something different from the other three. So isolation is when we are talking about multiple transactions. So atomic, only one transaction, consistency, only one transaction, but isolation, when we have multiple transactions, at that time we will talk about isolation. Okay, so when multiple transactions are there and we need to run them, so which one should we run first, which transaction should we run after that? So that's what we need to determine. So that is what isolation is. So we will isolate each of these transactions from other transactions so that the other transaction does not have any effect on another transaction. Okay. Last one is durability. Durability simply means when a transaction is done and all the changes are committed. Committed simply means we have saved everything. Okay. Then those changes must never be lost because of any subsequent failure. So if we save something or commit something, in database term, the term is commit. Okay. So if we commit something, after that, even if the system fails, everything should be there. Okay. So that is what durability means. We need to make sure that all the things are there as it is. So these are the four properties. We will talk about all of these one by one, starting with consistency. Consistency should be the easier one. So consistency, how should we ensure? So what do we have to ensure? That, like I said, all the constraints are satisfied. That is the thing that we need to make sure. That when we are running transactions, we need to make sure all the integrity constraints that we have in our tables, in our whole database, all of those are satisfied. And definitely new database states satisfy the specification of the transaction. What does the transaction wants to perform? They can perform all of those things in that database, right? Like I said, each transaction must have to preserve the consistency. However, this consistency is the responsibility of the application developer. The DBMS system, like one we are using, PostgreSQL, or let's say Oracle. So those DBMS system does not provide that guarantee that database will always be in consistent state. It is on us as a developer to make sure that everything is fine. Why DBMS does not provide that one, but we have seen if it is primary key, foreign key, declare system automatically completion. Yes, those sort of things system will guarantee, right? But think about you are withdrawing $100 from account A, but only depositing $90 into account B. System will never complain. System will never say that you have $10 short. So for this one, you are writing an update query. For this one, you are writing an update query as well, right? So those update queries will run it as it is, but you made a mistake, right? You withdrew $100, you should have deposited $100, but since you are writing the query in correct syntax, then everything will be fine. DBMS system will not complain. But at the end of the day, we'll see that you have $10 short, right? So that's what means that to make the transactions consistent, this is the job of the application developer to write bug-free code or bug-free transactions, okay? Although I have seen this one very quickly or very easily that all database constraints are satisfied inside a transaction, but these constraints might be violated in intermediate state. What does that mean? So now think about transaction means a group of statements. Think about we have hundreds of statements. Okay. Now after writing or after running 50 transactions, database becomes inconsistent. But if I run all of those, if I run 100 of those, if I keep going, okay, and finish all the statement, then database will be in consistent state. So that's what this one is saying, that constraints might be violated in intermediate state. But as long as when the transaction is finished, everything is fine, we'll say, okay, the transaction is valid transaction. Okay, why that might happen or how that might happen, let's have a look. Very simple example just to show you. Think about I have these two tables, unit of study and lecturer. Lecturer ID is the primary key. In unit of study, this is the primary key, and lecturer ID is the foreign key. That's what we can see in here. That this is the primary key unit of study code. Foreign key is lecturer ID, references lecturer. This part should be understandable. Deferrable, but now initially immediate. Deferrable means I can defer that one inside the transaction. If you remember from week 6. Initially immediate means after every statement we will check whether everything is fine or not. Right. Now think about this is the transaction that I have. What do you think will happen? Will it be okay? Remember initially immediate from week 6. Insert some data into unit of study table, insert into lecturer table. Will this be okay or will this return an error? Anyone have any idea? Insert into unit of study, values, these are the values that I want to insert, and then insert into lecturer, values 3 Stephen CSE. What do you think will happen? Will we be able to insert the data? Yep, someone is asking what does the meaning of deferrable initially immediate? Deferrable means we can defer the checking inside here, but initially immediate means after every statement it will check whether system is in correct state or not, in consistent state or not. Someone said it will be okay. Someone says set a defer on that foreign key. Yep. So this foreign key condition checking is deferred. We can change that behavior. That's what deferable means. So what do you think? Will this be okay? Someone said no lecture ID 3. Yep. Anyone else can find anything? Yeah, so have a look. This one is saying initially immediate. Initially immediate means after every statement we will check. So this is the first statement we are going to insert. So if I am going to insert this one in unit of study table. Since lecture ID is the foreign key, right? I am trying to insert 3, but 3 does not exist in the lecturer table. What will happen? Definitely there will be an error, right? Because we are checking after every statement. That's what is written here, initially immediate. So immediately we will check. After executing every statement, we will check whether this is right or wrong. This is definitely wrong. So system will return an error in this case. Okay. So what can we do? But now we can see that if I keep running, right? So if I run this one somehow, yep, someone is asking what does deferable means? Deferable means inside the transaction, we can change its behavior. We can change it to something else. If you remember some other options that we had, I will show you, right? So other option that we had is deferred, right? So if I set this constraint at deferred inside this transaction, now what does that means? Now I am deferring this checking until the transaction is complete. When the transaction is complete, when I find this commit. So when I get this commit, that means the transaction is complete. So if I write this line, set constraint foreign key deferred, that means I am deferring this checking. Okay. So at that time, what will happen? It will allow this insert. Why? Because he is not checking. This one is deferred. It will only check when the transaction is complete. And then it will insert this data. These two, after inserting this, he found a commit. That means the transaction is finished. Now he will check whether everything is fine. Is everything fine now? Yes. Right? Because we have an entry 3 in here, and that's what we are using in here. Right? Someone is saying deferring the constraint check to the very end of the transaction. Yes, that's what deferred means. That's what we learned on week 6, that until the transaction is complete, we will not check everything. Once the transaction is complete, we will check whether something is violated or not. Does this one make sense? So the only thing that I am showing you in here, that inside the transactions, we might have some case where there is some violation. So in this case, you can see that there is a clear violation. But if we keep running, and that we can do using this option that we have, okay, then everything might be fine. Someone is asking, what if we insert into lecturer first? If we insert into lecturer first, then there is no issue, right? So there is no error anywhere. If we insert the data in lecturer table first and then in unit of study, then there is no issue, right? Because in lecturer table, there is no such condition. This is simply primary key 3 is fine, we'll insert, and then we'll insert into unit of study. So that's fine. Someone is asking, if no defer, that can happen error. Yes. So if I don't defer this one in this line, definitely after this line, there will be an error. Okay. Someone is asking, what happens if we don't use deferable initial immediate? That depends on the setting that we have in our DBMS system. Anyone remember what was the default setting we learned in week 6? What was the default setting? So the default setting was, he checks, yep, not deferable. Yes, that was the default setting. So he will check after every statement whether everything is fine or not. Right? So that was not deferable, will not defer that one. So think about once you run a query, does the value, let's say you have an insert query, does the value stored in the database correctly? Yes, right? So if I run a query insert into, say, lecturer, these are the values, and run in PostgreSQL. After we go to PostgreSQL, we see that value is there, right? But today we are learning about this commit, that when I write the commit, then only he saves everything, right? So what he does, after every statement, he runs a commit. Okay. So that was the default option. I'll talk about this one more today. Okay. So again, that depends on your setting that you have in your DBMS system. Okay. So by default in DBMS system, everything is checked after every statement. Okay. So if you don't write anything, this one will definitely be an error. Okay. But we can change that behavior using this deferable option that we had. So that's it about transaction, about consistency. Someone is asking, if it is not marked as deferable, can I change it at defer? No, we cannot do that. You first mark this, have to mark this one as deferable. Okay. If you don't write it as a deferable, you will not be able to change it later. Okay. Deferable means yes, you can change that one. Okay. So that is the only thing that we have to deal when we are talking about consistency. Hopefully making sense. Any other question on consistency? Okay, let me move on. Next one is atomicity. You remember what does atomicity means? Atomicity means either 100% or 0%, right? How do we ensure that fact? So a DBMS system, when we have a transaction, okay, it will always execute all the operations in one step, not executing any operation at all. So that is what atomic means, either 100% or 0%. Every transaction should act as an atomic operation, as a single operation. Example, I have already shown you, like bank transfer, there we might have to do withdrawal and deposit. We either have to do both of them or neither of them, right? So if something like the error that I have shown in the first slide, that if I was able to withdraw from an account but was not able to deposit into another account, at that time, what can we do? So we have to actually undo all the previous operations that we have done. Okay, so this is what I'm talking about. Let's say in a transaction, there are 5 statements, okay, and then there is a commit in here. So after running 3 statements, everything was fine. And in here, now I have a crash. System crashed due to many issues, okay. Now what can I do? So only thing that I can do, because I don't have that option to run the next ones, because the system is gone. So now I cannot reach 100%. So what I have to do, I have to undo all the operations that I have done. Okay. So pressing Ctrl-Z, Ctrl-Z, things like that. Whatever you have done, undo all the operations. Now, if you want to undo, okay, then you definitely need to remember what you have done. Because if you don't remember what you have done, you will not be able to undo those operations. So that's what is written here. DBMS logs all the actions. So whatever I have done, it will write that one in the file. That file is known as log file. In that file, he will always remember what he has done. The system has done so far. So he will remember that he has run these 3 statements. Okay. If I need to perform any undo operations, at that time, he will go to that file, have a look what are the things that he has done. So he will undo all of those. So in the case of a failure, all actions of not committed transactions are undone. If I cannot reach commit, that simply means that all of these are uncommitted. So you will undo all of those using this log file that we have. Someone is talking about rollback. Yes, I have not used that term yet, but we'll talk about rollback too. But probably if you are familiar with rollback, you understood that is what I am talking about. Okay, so this is what we are trying to do. If the transaction is successfully completed, that means 100%, it is said to be committed. We'll use this term commit. Okay, that simply means everything is fine. After that, it is the DBMS job to ensure that all the changes are saved. That is durability issue. Okay, we'll talk about that. If the transaction does not successfully complete, it is said to be aborted. Or the term we use in here is rolling back. The keyword that we will use in our system, you will see, is rollback. Okay, so DBMS will undo all the operations that we have performed for a particular transaction so far. Why we might have to abort? Many things, like the one I'm saying again and again, system might crash. Transaction can be aborted by the system. System can forcefully abort some transaction because of, let's say, timeout error, because the network is too slow, taking too much time. So system can abort any transactions that we have. There might be some violation of constraint. So if there is a violation of constraint, definitely we cannot move forward. So at that time we have to abort, right? Or transaction can specifically request for rollback for any issues. Okay, so inside the transaction we can write rollback as well if needed for some reason. Okay, so these are the three things that we will use. Begin, to identify what is the beginning of this transaction. So when we want to write a transaction, we will start with begin, then we will write all of the statement that we want to write, then we'll write commit if everything is fine. Okay, then we'll write commit. It will commit the current transaction. Commit means it will save everything. Rollback simply means that it will undo all the operations that we have. Okay, so if once rollback starts, it will always be satisfied. Okay, you can stop that. It will undo all of those operations that you have done. We can set this auto commit off or on. Okay, we can write set auto commit off, set auto commit on. In our DBMS system, what is the default behavior we have right now? Is it on or off? Definitely it is on. That's why we don't have to write again and again commit, right? So we just create table, create this table, we execute that query, we see that table is there. Why? Because in our system, auto commit is automatically on. If you want to change that behavior, you can set that one to off. Okay, if needed. Why someone might want to turn off the auto commit feature? Any idea, anyone? Why I would want to turn off the auto commit feature? Think about transactions. Especially, someone is saying in case of misinput. No, auto commit off means it will not automatically save what you are doing. No. Someone is saying ban transactions can be undo by user. No. I'm talking about something else in here. Auto commit on or off means when I am writing all of the statement in PostgreSQL, right? Since auto commit is on, so when I write a statement, insert into, let's say, student, all the values, then that is saved. Because auto commit is there, that simply means after every statement, there is a commit. But when I have a group of statements, now think about what is happening. In a transaction, let's say I have 100 line of code, 100 SQL query, and you are committing after every statement. Do you want that? That will take too much time. That will take too much time, right? If inside a transaction, after, think about you are writing in a Word document, you are writing one line, pressing Ctrl S, again one line, pressing Ctrl S, again another line, pressing Ctrl S, again one line, pressing Ctrl S. That's what you are doing when you have auto commit on. That's what he will do. After running every statement, he will try to save everything. That definitely takes time, right? But if you have auto commit off, That means it will not automatically commit everything. Only when you write the commit, at that time you will commit. So we'll definitely write a commit at the end of a transaction, right? In here, there will be a commit. So when it reaches a commit, it will only commit at that time. So that simply means we'll write everything, right? We'll execute everything. And when everything is done, only then we'll commit. Hopefully making sense. This feature, depending on you, depending on the application, client can have different configuration. Okay. We'll run very small applications. In that case, we will not see this effect. Okay. But when we are talking about large transactions, at that time, this one will be in effect. Okay. But main thing is you can set that behavior on or off in our DBMS system. Okay, so that you understand commit and rollback, think about this transaction, and I want to figure out what will be the value returned from the select statement. 1, 2, or 3. You can simply write 1, 2, or 3 in the chat box. So this is the table. This is the course table. Here I have a unit of study code as the primary key because that is underlined, and updating that course, the lecturer ID of that course table, where unit of study code equal to this one. Then commit. Then I am selecting lecture ID from this course table where unit of study code equal to this one. Which one will be the output, 1, 2, or 3? Three people have said 1, 1, 1 so far. Yes, everyone that have written the answer, everyone is saying 1. Yep. This one will be 1. Why? Probably understood. Lecture ID equal to 1, 2, 3, 4. That's what I'm trying to say, where comp equal to 5, 1, 3, 8. So for this comp, I am changing this one or updating this one to 1, 2, 3, 4, right? And then after that, I am committing this one. Committing simply means I'm saving everything, right? So this 1, 2, 3, 4 is now saved. Then I'm trying to see what is the lecture ID there. So select lecture ID from course where course ID equal to COMP9138. So COMP9138, definitely we are going to get 1, 2, 3, 4, right? Excellent. What about this one? Only change is instead of commit, now I have a rollback. What will be the result in this case, 1, 2, or 3? Excellent, everyone. All of you are saying 2. Why? Because this time I have a rollback, right? So if I roll back everything that I have done, although this value will be there, 1, 2, 3, 4, but since I'm rolling back, that simply means it will go back to the previous state, right? So hopefully that is making sense. So it will be 2. Now, this one should be interesting. Have a look at the question very carefully and then try to figure out what will be the answer in this case, 1, 2, or 3. I'll not say anything more. Have a look at the question very closely and then answer. Most of you are saying 2. One person said 1. Another person said 1. Everyone else is saying 2. Okay, so first of all, have a look. What is it that we are trying to do? I'm trying to change the lecture ID to 4, 5, 6, 7. Can I do that? Definitely not, because this time lecture ID is the primary key, right? This is underlined. So lecture ID is the primary key. So I cannot do this one. So although I have a commit, but because this is violating constraint, so this transaction will not be successful, right? So since this one will not be successful, after that, if I select the lecture ID, definitely I'm going to get 3, 4, 5, 6 because there is no effect of this transaction because this transaction was unsuccessful. Hopefully that is making sense. Once again, I'm trying to set 4567, but I already have 4567 as a lecturer ID. Since lecturer ID is a primary key, I cannot insert the same value twice. So this transaction will be aborted. Right? So although I have a commit, but this is a failed transaction. Okay, so since this failed, no effect in here, I am going to get 3456. Hopefully making sense. So last week we learned about JDBC, and for Python we learned about DB API, right? So how do we write all of these things in that JDBC if we're creating an application? Okay, very simple. In JDBC connection class, there are 3 methods available. Just looking into the method name, you can understand what does this mean. Set auto commit true or false. If true, that means after every statement it will check or it will save everything. Commit and roll back. If you need to commit, this is the method you are going to call. If you need to roll back, this is the one that you are going to call. Okay, so very simple. So these are the 3 new lines that I have today. These 3 lines. Okay, so everything else we have talked about during week 7 last week. So after creating a connection, you can set this auto commit to true or false. If true, then auto commit will be on. If false, then auto commit will be off. Okay, if we are successful in running this transaction, we can commit. So in this query, we are trying to update only 1 row. If only 1 row is updated, then we'll commit. If more than 1 row or 0 row has been updated, then we'll say something is wrong, then we'll roll back. So these are the 2 methods we can call inside JDBC. Definitely, if you are writing rollback explicitly, you need to write rollback before you close the connection, because if the connection is closed, then you cannot undo anything, right? So sometimes people make a mistake and do this rollback after closing the connection. That's why they see different results. Okay, but you can understand if the connection is closed, then the rollback cannot be done. Right? So you need to make sure that you do that before closing the connection. What about Python? So that was JDBC, that means for Java. For Python, same thing. We have method for commit and for rollback. Only change is that auto commit is now an attribute, not a method. Okay, in Python DB API. That is the only change. Other than that, everything is fine. So now you can see that this is not a method. This is an attribute. Con.autocommit equal to true or equal to false. That will set it either auto commit on or off, and these are fine. Rollback, commit, those things are there, right? So only change is that this has become an attribute instead of a method in Python. Okay, so that is atomicity. Any question on atomicity? We'll talk about durability. Just a little bit. We'll not go into detail of durability. Then we'll have our break. Okay. No question, looks like. Okay. Durability. What does durability means? Durability simply means once we commit something, that data must be there, whatever the case is. Even if the system crashes, everything is gone, but we expect that data to be there. If you have experienced this one on Facebook, WhatsApp this week, right? Facebook, WhatsApp was down for 6 hours, more than 6 hours, I guess. What do you expect when Facebook comes back up? If every data of you that you have in Facebook, if everything is gone, will you be happy? Definitely not, right? If you are an ANZ bank customer, today ANZ is having some outage and you cannot use ANZ mobile app or the app that we have to transfer any money today. So a lot of people are complaining. I just saw in the TV, a lot of people are complaining that they cannot pay for their groceries. They're going to Kohl's and Woolworth, but they cannot pay because their card is not working today. And finally, ANZ says, sorry, we are having some issue with our system. Okay. So that is what durability means. So durability means even if this sort of problem occurs, after the system recovers, everything should be there. If every person's bank account information is gone because there was some issue, you will not become a customer of that bank next time. No one will. So transactions should be durable. That is the main thing. Anything that we commit should be there even if the system crashes. There should be some mechanism there. So this one is specifically talking about physical thing. Where do we store the data? Okay. So in case of media failure simply means in the physical storage when we store the data. Where do we store the data? In our computer, think about in the hard disk, right? What if your hard disk fails? Then everything is gone. Now think about bank application. They also store the data somewhere, right? In a data in a hard disk. If that hard disk is failed, then everything will be gone. So how do they ensure that even if that hard disk fails, because that might happen, every data is safe? Simple thing for durability, that is the one that we are talking about today, is they follow a model called RAID. That simply means we will back up everything that we have. Okay. So whatever we have, we will back up all the data into some other storage. So that will reduce the chance that both of them will fail at the same time. That might not happen. The probability is very low now, right? So even if the first one crashes, we still have the data in the backup one, right? Even if the backup crashes, then we have the data in the original one, right? So that model is known as RAID. This is definitely redundant, right? Why? Because you are storing the same data twice. First in this hard disk and also in this hard disk. So this one is known as redundant array of inexpensive disk. In short, RAID model, that is what is the name. Okay, you will see for durability. We'll not talk about this one because this is talking about physical storage. On week 11, we'll learn about physical storage. There we'll have some insight from here, okay, but not today. Main thing, to ensure durability, every system that we have, they back up everything into another storage. Okay, that is definitely redundant, but that is useful or that is needed for ensuring durability. Now, just a little bit insight that what will happen when I'm writing some data in here. Okay, I just wrote the data, right, in here. And then when I'm going to write the data in here, the system fails. Right? So the same thing might occur that I have written the data in here correctly. I'm going to write the data in here, but I cannot because the system fails in the meantime, right? So when the system comes back, so that everything is consistent, he still needs to write this data into this backup one, right? So how does he remember? This time he remembers using a log file called write ahead log. What does that mean? That means whenever I am trying to insert some data into this storage, let's say I'm trying to insert one student information into this storage. Before writing this one, I will write into a log file that I am going to write this student data into this one. So simple log file. I perform that operation. So I insert that data in here. If I am able to insert that data in the backup as well, then I'll simply remove this log file. I don't need that one. But if the system crashes, I cannot write in the backup. So in this log file, I have that information. What is the thing that I have done? I only said about one statement, but since we're talking about transaction, now you can understand this is a collection of statements there, right? So we run one transaction, made all the changes in this original one, write that one into a log file that these are the changes that we have made. If we can write that one in the backup server as well, then everything is fine. We don't need this log. We can delete that one. But if the system crashes, in the log file, we know what is it that we have done. Okay, so that when this one comes back up, using this log file, we will write this one in here. Okay, so hopefully that is making sense. So durability simply means backing up everything that you have. Okay, so that if something goes wrong, you will still have a backup to recover from. That's what durability. Will not go into detail. Next thing is isolation. That one will take fair amount of time, a lot of time. Okay, so we'll take a break. How much break we can take? 5 minutes of break, and then we'll come back for isolation. In the meantime, if anyone have any question, feel free to ask regarding consistency, atomicity, or durability. So come back on 6:55. We'll start then. Okay, I'm back. Hopefully everyone is back too. Any question, anyone, regarding these first three? Everyone is very quiet today. Everyone is thinking about assignment. Okay, looks like no question. Okay, so let me move on isolation. Yeah, so all the three things that we have seen, consistency, atomicity, and durability, all of those things are when we are only talking about one transaction. So in these three cases, we are talking about only one transaction. Now, when we have more than one transaction, we have at the same time, at that time, we need to think about isolation. So transactions should be isolated from the effects of other concurrent transactions. So concurrent transaction means those transactions come at the same time. If two transactions comes to you at the same time, then what is it that we can do? Someone is asking, in final, are we be required to write JDBC transactions? No. JDBC and DB API, those are only for assignment. Okay. Assignment 2. Okay, so when we have multiple transactions coming to us at the same time, at that time, one transaction should not affect another transactions, right? So normally the DBMS system that we use, it can handle multiple transactions. And today in the tutorial session, you will see we have that thing, we will perform 2 transactions at the same time. Okay. So DBMS system can handle their situation. That's fine. So how does it handle that? That's what we are going to do. So what does that mean? Think about these are the 2 transactions, T1 and T2. In T1, we are trying to transfer $100 from account A to account B. So we simply subtract $100 from A and then add $100 into account B. Right? So that is what transaction 1 is. In transaction 2, we are trying to increase all of these account values by 5%. Let's say, so A equal to 1.05 into A and B equal to this one as well. So these are the 2 transactions that come to us at the same time. Now, which one should we run first and which one should we run later? Because we can run only one at one time, right? But both of them came to us at the same time concurrently. So what can we do? Before moving forward, we'll assume all the transactions commit. That means all the transactions will be successful. Okay, there is no aborted transaction. That is the first assumption we are going to make, that all the transactions will be successful. Once they start, they will be successful. Okay. Assuming that one, which one should we do first and which one after that? So what can we do? First, think about serial execution. Serial means whatever the order, the transaction coming to me, I will always perform them one by one. So I can choose T1 first and then T2, right? So I will perform everything from T1, then I will perform T2. Or someone might say, why I want to perform T2 first, because both of them came to me at the same time. Yes, that's fine. You can do that. You can perform T2 first and then T1, but definitely the result will be different, right? So which one you are choosing, depending on the result, will definitely be different, right? But that's fine. We are not worried about the result for the time being. We are only worried about how can we run those transactions. Okay. So let's say you are either this first one, T1, T2, or T2, T1. That means first T2, then T1. What other option do we have? So these 2 are known as serial. Another one is known as interleaved. Interleaved means some part from T1. You can see I'm performing some part from T1, then something from T2, then something from T1, and then something from T2. Okay. First of all, can anyone think of any advantage of this approach? Why I want to complicate things? Any advantage you can think of? Because this is the one that we will talk about for 1 hour today, okay, for the next 1 hour. Any advantage you can think of rather than doing this serially, First, if you start T1, then complete T1, then start T2, then start T3, those sort of thing. But in here, we are partially completing one transaction, then another transaction, something like that. Any advantage you can think of? Someone is saying lock, someone is saying saving time. Yep. Yep, definitely we'll save some time. Lock, we'll talk about lock later. How it will save some time, right? This interleave one. Any idea? Someone said it's saving time. That is correct. Can someone guess how it might save some time? Someone is saying main forces on changing A, secondly, main forces on changing B. Someone is saying you can complete one account first, then another. Okay, so you are thinking first perform something on A, so all the operation on A, then all the operations on B. But the question is, how does that one save some time? There are two ways it can save some time. Okay. Someone is saying kind of like hit and cache. No. Parallel processing, no. No. Parallel is something different. Parallel simply means we'll perform both of them at the same time, right? But this is still serial. At one time, I can perform only this and then this. Okay. Someone is saying this seems saving no time. No, but we can save some time. Let me give you some clue. Think about waiting time. Two customers are there at the same time. Okay. And you are trying to serve one customer and then another. Or you can perform some operation of that customer and then something from other. Read write time, someone wrote. Okay, so let me move forward and there I'll explain. So first one was serial, nothing interesting there. Okay, so we'll perform one transaction and then another. Okay. But in interleave, it will improve performance by saving time. How? Some transactions may be slow and long running. If, let's say in this case, first transaction takes 10 seconds to perform, T2 have to wait for this 10 seconds. He has no other way, right? So T2 have to wait until T1 is complete. So that's what this one is saying. Some transaction may be slow and that is affecting all the other transactions, subsequent transactions. Something might be long running. It has a lot of statement. Some transaction have 100 statement while the other one has only 2 statement. Okay, but if you start the 100 statement transaction first, unless you complete all of them, you cannot move on to the next one. Right? So it blocks all the subsequent transactions. If we interleave them, something from T1, something from T2, then we can minimize definitely the waiting time and the long running impact will not be there. We'll talk about more, don't worry. Another important thing is disk space. Someone's talk about read and write, someone said yes. So think about, in this case, let me give you an example. Let's say I want to do A equal to A plus 100. A equal to A plus 100. Okay, this is what I want to do. What is the operation that I'm doing in here? To perform this operation, first thing that I have to do, I first need to know what is the current value of A. If A's value is 500, then I will add 500 plus 100, right? So first I need to read the value of A. Now, when I'm reading, who will read that value? CPU will not read that value. That is disk access, right? So that is the job of the disk. So disk will read all of those values. That is definitely slow compared to CPU. I'm guessing all of you know that. CPU is much more faster. CPU only performs this addition operation, right? But when the data is being read, CPU is idle. CPU is doing nothing at that time. CPU is waiting when the read will be complete. Disk goes to the database, finds the appropriate table, checks all the conditions, figure out the data, then transfer that data from hard disk to main memory. Then CPU have access to that one. Then CPU can perform some operations. But in the meantime, when all of these reading are happening, CPU is sitting idle. CPU is doing nothing. But if we interleave something, that when some read is happening, at that time we can perform some operation for other transactions using the CPU. Right? So that's what the idea is. That's how we can save some time. Hopefully making sense that interleaving improves definitely the performance. Now, if we perform something like that we are interleaving all these transactions, can we do that arbitrarily? Definitely not, right? So definitely that will give us wrong result. So which interleave schedule is right and which one is wrong? We want to figure that one out. To figure that one out, we will learn a concept of serializability. A schedule, whenever I'm saying schedule, from now on think about interleaving schedule, because serial schedule, that is not interesting at all. Okay, so we'll perform one by one, that's nothing. Whenever I'm writing schedule, think about interleaving schedule. A interleaving schedule is serializable if it is equivalent to some serial schedule. If equivalent means the output will be same as running them one after another, whatever the order is, that doesn't matter. If two schedules produces the same output, we'll say these two schedules are equivalent. Okay, and that interleaved schedule will be serializable. Let me just give you an example. Think about this interleaved schedule. This is the same one that I had here. Is it serializable? What do you think? This interleaved schedule, is it serializable? How do we check that? The output of this schedule need to match with either T1, T2 or T2, T1. If it matches with at least one of them, then we'll say it is serializable. Just looking into this one, can anyone guess whether it is serializable or not? Yes, no? Let's say this one is 1, this one is 2, and this one is 3. I'm asking, is number 3 serializable schedule? If yes, then it is equivalent to which one, 1 or 2? One person said 1, another one is saying 1. It looks like 1 is winning. 1. Yes, excellent job. This is definitely serializable and this is equivalent to 1. All of you are right? How do I check that? We can create all the equations, right? So what will be the equation for this one? What is the final value of A? So this is the final value of A, right? So that's why I have written AF, so that you understand this is the final value. You got 1.05 into A. A means whatever value is coming from here. So that is AI, that means the initial value of A minus 100. And B, what is the value of B? We can figure that one out. So if we look into T1, T2 and figure out the equations, you can see the exact same equation. For the other one where I had T2 and T1, I definitely will have a different equation. Right? Just looking into these equations, I know that this interleaved schedule is serializable and it is equivalent to running T1 and T2. Hopefully that is making sense. If that makes sense, think about this one. Is it serializable? If yes, think about T1, T2 or T2, T1. Which one is it equivalent to? First thing, is it serializable? you have two options. You can run T1 first, then T2, or T2 first, then T1. I only have two transactions in here. Is it equivalent to this one, or no one? That's what we want to figure out. Yep, excellent job. Everyone is saying no. I'm not sure whether you are looking into this non-serializable, because this is an example of non-serializable, or you have actually calculated. I'm guessing you have calculated. If yes, then excellent. So yes, this is not serializable, because again, if we figure out the equations, okay, we'll see that the equations differ. This is the equation for this interleaved execution, and this is the equation for these two. Okay, and the equations are different. So this is a wrong interleaved execution. That simply means that is non-serializable schedule. Okay, we'll not be able to perform this one. Hopefully making sense. Now, to check whether an interleaved schedule is serializable, when I had two transactions, it was easy. If I have three transactions, T1, T2, and T3 coming at the same time, how many checking do I have to do? In this case, two, right? T1, T2, and T2, T1. Forget about no. That is, if nothing matches, then that is no. So when I had T1 and T2, I have to make two check, whether it is equivalent to T1, T2, T2, T1. If I have three transactions, how many check do I have to do? Someone said 3, someone said 6. Looks like 6 is winning. Someone said 3. It will be 6, right? We'll check everything. T1, T2, T3, and all the other combinations. So T1, T3, T2. So we need to check all the combinations, right? So it will be 6. What other do we have? T2, T1, T3, T2, T3, T1, and everything else, right? And the 2, starting with T3. So that will be 6. What about 10? How do we calculate that? Or what about n? If I have n number of transactions, how many checking do I need? Yes. Someone said it right. Anyone else? Yep. Factorial n. Excellent job. So is it feasible to do? So if I have 10 transactions, so I have to do factorial 10, which is a huge number. Can we do that? Definitely not, right? So it will take a lots and lots of time. So we'll definitely not do that. So how can we check the serializability of a transactions? To do that, we will learn something about conflict serializable. Okay, so once we understand conflict, then we will see that it is very easy to check whether something is serializable or not. We don't have to check all of this factorial n. So this is what I was saying. Serializability is very hard to check. We need to check with all the consistent state that we can think of. That means factorial n. Okay, we'll definitely not going to do that. So we want to analyze the schedule without executing them, without checking one by one, or executing one by one whether the output is equal. How can we do that? To understand that, first thing that we need to do, we need to learn about how DBMS sees this operation. The DBMS view of a schedule. So when we submit some transactions to the DBMS system, what does DBMS sees? Okay. So when I'm trying to write this line, a equal to a minus 100, what DBMS sees is that what DBMS understands from that line is that he needs to perform a read operation and a write operation. Can you understand that? Why read? Because first he needs to figure out what is the value of a. Then he calculates a minus 100. Then this value is a. He needs to write that value back to the database. Right? So this one first he needs to read. And then you need to write this one back to the database. So this is what DBMS is. So if I give him this transaction, this is what the DBMS sees. Does that make sense? Have a look. R means read, W means write, 1 means coming from transaction number 1, A means the data item on which we are working on. Okay, so first R1 means in transaction 1 you first need to read A, then you need to, in transaction 1 you need to write A. This is what it says. Does that make sense for all of these equations? Have a look. So this is what the notation means. R means reading, W means writing, R1 means we are referring to transaction 1, R2 means reading from transaction 2, W1 and W2 means writing from transaction 1 and transaction 2 respectively. Hopefully making sense. So this is what the DBMS is. Okay, he does not bother about plus, multiplication, minus, he only sees reading and writing. Okay. Okay, now since we have this idea of reading and writing, now we can define conflict. Conflict. What does conflict means? Two operations are known as conflicting pair if they are coming from two transactions AI and AJ. Three conditions need to meet. Okay, remember these three conditions. If three conditions are met, then they are in conflict. First condition, they access the same data item X. If two operations in the transactions are working on the same data item, then there might be some conflict, right? If someone is working on X, someone else is working on Y, then there is no conflict, definitely. So the first condition is if two operations are working on the same data item. Second condition, they come from different transactions. Okay, if they are from the same transaction, no conflict is there, because in the same transaction we always perform one by one, right? If the reading is there, we'll perform the reading, then writing. In the same transaction, there is an issue. Only when they are coming from different transactions, at that time there might be some conflict. And the last one, the important one, is at least one of them is writing on X. At least one of them is writing. If all of these three conditions are met, then we'll say AI and AJ are a conflicting pair. Once again, remember these three conditions. First, they are working on the same data item. Second, they are coming from different transactions. Third, at least one of them is writing X. That means changing X or updating X, right? Once again, they are working on the same data item. They are coming from different transactions. At least one of them is changing the data. That means writing. Okay. So that simply means if I have read and read, then there is no conflict. Simple thing. If there is read and write, then they conflict, right? Write, read, they conflict, write, they conflict. Providing that these AI and AJ are not equal. They are different transactions. Okay. Hopefully making sense. Just to make sure that you understand, this read write means nothing but simple select and insert, update and delete. Select means reading the data. When you write something like insert, delete, update, then that simply means writing, right? Because you expect to write this one in the DBMS system. So when you write insert query, he simply sees a write operation. When you write a select query, he simply sees a read operation. Okay. Okay, so now we have this idea of conflicting pair. Hopefully we'll be able to determine whether two things are conflicting or not. In the next slide, I have some exercise, we'll do that. But before moving there, another thing is once we figure out the conflict, now we want to figure out the conflict serializability. What does that mean? Conflict serializable means there is some conflict, that's fine. We'll allow the conflict, but it is still serializable. Okay, so conflict equivalent means they involve the same set of operation on the same transactions. So if we are in the same transaction, then we'll perform the same operation. Definitely, that condition is 99% time satisfied. Second condition is the interesting one. They order every pair of conflicting operation in the same way. What does that mean? The order is important. That's what this one is saying. So in one transaction T1, if I'm reading first and then writing, there's X. In another transaction, the order must be same. First read, then write. Then we can say these two might be equivalent, right? That should be understandable. This one is reading first, then writing. If other transactions have to be equal, then they need to keep the same order. If they change the order, first write, then read, they might get different result, right? So that's what conflict equivalent is. Let's see some example, then hopefully this one will make sense. How do we figure out that conflict, right? So now we are going to learn a very simple technique called precedence graph. Using precedence graph, you will see this is very, very easy to figure out whether something is serializable or not. Okay, first thing is graph. If you are not familiar with graph simply is something like this, where we have some node or vertices, we say, okay, and there are some connections between them, and those are known as edge. Okay, so these vertices will be my transactions. So that's what is written here. Okay, direct graph where vertices are the transactions. So T1, T2, T3, and then these edges will be the connection between them. Which one I need to perform first, which one I need to perform second. Okay, so that's what we are going to draw. And that graph is known as precedence graph. Okay, very easy to draw. Think about this one. First, answer this question. How many conflicting pairs are here in these two transactions? 1, 2, 3, 4, write in the chat box. How many conflicting pairs are here in this example? Someone said 1, someone said 3. Another person said 3. 3. Looks like 3 is winning. Someone said 2. So I have answers 1, 2, and 3. Someone said 1, someone said 2, someone said 3. Most of you said 3. Before I move forward, or before I give you the answer, is this a conflicting pair? Just answer that question first. Yes or no? Is this a conflicting pair? Yes, definitely not. Someone said yes, but you are wrong. Definitely not. That is not a conflicting pair. Why? Because these two are coming from the same transaction. What was the second condition? They need to come from different transactions. So these two are not conflicting. Okay. Okay, so we cleared that one out. Is this conflicting? No, everyone said no. Why? Because both are read. Third condition was at least one of them have to be right. Right? Since two conditions are met, they are working on the same data item, they are coming from different transactions, but at least one of them have to be right. That is condition is not met. What about this one? These two, are they conflicting? Yes, everyone said yes. So we found one conflicting pair. What is the other one that we have? Think about this one and this one. R2C and W1C. Is this conflicting? Yes, because of the same reason of this one. What is the third one? What is the third one you have found? Yep. Excellent. Yes, so you found these two as well. Good job. W2C and W1C, this is a conflicting pair as well. Right? So this one have 3 conflicting pairs. So that is the first thing you need to determine. When I give you a transaction, okay, set of transaction, you need to figure out how many conflicting pairs are there. Once you figure that one out, then we'll draw a graph. Okay, so there will be vertices in a graph. Vertices simply means these circles. So T1 and T2, I have only 2. Then I need to draw an edge between one vertex and another. How will I draw an edge? Depending on the relation that I have. Think about this one first. R1C and W2C. So that simply means there is a connection between T1 and T2. There is a conflicting pair between T1 and T2. And which one are we performing first in this schedule? We are performing R1 first and then W2, right? According to this schedule. So that's why we'll draw an edge in here, but the arrow will be from T1 to T2. Does that make sense? Have a look why the arrow is from T1 to T2. This is very important. If you draw the wrong arrow, then it will not work. Because in this case, first we are reading in T1, then we are writing in T2. Hopefully that is making sense. That's why we are going from T1 to T2. This one is saying first perform T1, first read, and then you can write in T2. What is the other conflicting pair is this one, W1C and R2C. What is it that we are doing first? Definitely R2 and then WC. So the arrow will be from T2 to T1. What about the third pair? This is the third pair that we have. So this one is saying from 2 to 1, we already have an edge from 2 to 1. We don't draw that edge again. Okay, so that's why I have 2 edges in here, although I had 3 conflicting pairs. Hopefully that is making sense. Now, once I draw this graph, what do you think is happening in here? This one is saying you need to perform T1 first, then T2. And then this one is saying you need to perform T2 first, then T1. Then you are in a cycle. Which one should you do first? You definitely cannot do anything first, right? So that's why this is not serializable. This is not, we'll say, conflict serializable. This is not conflict serializable because we have a cycle in here. The theorem says it is conflict serializable if the graph is acyclic. Remember this A. If this is acyclic means there is no cycle. Okay. If there is no cycle, only then we will say that this is conflict serializable. Okay. Hopefully making sense. Again, I will give you a set of transaction. You will draw this graph, figure out whether there is a cycle. If there is a cycle, you will say, no, this is not conflict serializable. If there is no cycle, you will say that this is conflict serializable. Hopefully you got the idea. Take a piece of pen and paper, if you cannot write, and figure out whether these schedules are conflict serializable or not. What about this one? Is it conflict serializable? Someone is asking the third conflicting pair. Sorry, I need to move back here because someone is asking about the third pair, this one. So this one is already an edge in here from T2 to T1, right? So that's why we are not drawing that edge. So if I need to draw this one, I have to draw this one again, right? So we'll draw only once. That's why there is nothing there. Okay. Someone said yes, someone said no for this example. Once again, try. Is it conflict serializable? Still someone is saying no, someone is saying yes. Someone is saying in case this is the right, which way should the arrow point? Depending on which one you are doing. So in here, first you will write into transaction 2 and then write into transaction 1. So from 2 to 1, the arrow will be from 2 to 1. So it depends on the order, not depending on R and W. Here we have all the reads, right? Here we have all read. That means there is no conflicting pair. Yep. If there is no conflicting pair, if I am trying to draw the graph, there will be no cycle. That simply means this is conflict serializable, right? All read, no conflict, so conflict serializable. Yep, in this case, there is no conflict, right? Because all of them are read. Okay, what about this one? Is it conflict serializable? Try to draw the graph, okay, and then answer. That one will help. First, figure out how many conflicting pairs are here. How many conflicting pairs are here in this schedule? Someone say 2. Which 2 we are talking about? Let's start with X. Is these 2 conflicting pair? Because I have a read and write. Is these 2 conflicting? No. Why not? I have read and write. Why they are not conflicting? Yep, different object. Thank you. So they are working on, this one is working on X, this one is working on Y. So great. Good job. Okay, so think about this R1X and any conflicting pair. What about W2X? These 2 are conflicting, right? Because we are working on X. This is read, this is write, this is transaction 1, this is transaction 2. What about the other one? These 2, right? Yep, you figured that one out. W2Y and R1Y. These 2 are the conflicting pair. Is there any conflict between these 2? No, because both are read, so no conflict. So now draw the graph. How many transactions do I have in this case? I have three transactions. T1, T2, T3. First conflicting pair is R1X and W2X. So I need to draw an edge from 1 to 2. Hopefully that is making sense because we will perform R1 first, then W2. So I need to draw an edge from T1 to T2. And for this pair, I need to draw an edge from 2 to 1. Right? There is another conflicting pair. Can you figure that one out? Oh, I just figured that one out. I can see another conflicting pair. Not 2, there are actually 3. Can anyone figure out in this transaction set of transactions we have another conflicting pair? Yes, right. Which one again? Which conflicting pair do I have? Someone said 2, right? No, these are working on Y and X. No, they are working on Y and X. There are no other conflicting pair. I just wanted to check whether you can figure that one out. And I can see that 2 of you fall into that trap and saying W2Y and W2X are conflicting pair. No, there is no other conflicting pair in here. Right? Now, is this serializable or not? This is definitely not serializable because I already have a cycle. From here, I need to go to T1 to T2, then T2 to T1. Right? So since there is a cycle, this is definitely not conflict serializable. Hopefully that thing is making sense. So this one is not conflict serializable. What about last one? What about this, the last one? Is it conflict serializable? First, figure out how many conflict you have. Then try to draw the graph somewhere in piece of paper, and then answer. One answer, someone is saying yes. Anyone else? Someone wrote the conflicting pairs as well. Okay. So first thing, we have to figure out how many conflicting pair do we have. So how many conflicting pair do we have in this case? Yep, 3. We have 3 conflicting pair in this case. R1X, W2X, right? R2Y, and then R3X, no, sorry. Y have no conflict. We have a conflict on R3X and W2X, right? And another one will be, which one is the other one? So R1X and W2X is one. Another one is R3X and W2X. This is another one. And the last one would be what is the third one that we have? Is this conflicting, W2Y and R2Y? No, they are working on the same data item, but they are coming from same transaction. Yep. So 2 conflicting pairs are there. Okay. I'm just giving you time to make sure of that. Okay, now try to draw the graph. T1, T2, T3. Draw the graph from R1X and W2X. So that simply means from T1 to T2, there will be an edge. And from 3 to 2, there will be an edge as well. No cycle, this is acyclic. That simply means that this is serializable, right? So this is serializable. Think about what does this graph is telling me. This graph is telling me that you need to perform T2 at the end, right? So you can perform either T1 or T3 first. And at the end, if you perform T2, then everything is fine. This is what this one is saying. We'll talk about that, but hopefully you understand that. So yeah, you might get some question like this in the exam as well. I will give a set of operation. You need to figure out whether they are conflict serializable or not. Another thing to remember, if a schedule is conflict serializable, then it must be serializable. Okay, so that is what we wanted to figure out, right? Whether this schedule is serializable or not. So if something is conflict serializable, then it is serializable. Someone is asking still about W2Y and this one and R2Y. They are coming from the same transaction, transaction 2, right? So they are not conflicted. Okay, so if something is conflict serializable, then it is serializable, but the vice versa is not correct. That simply means that something is serializable does not mean that they are conflict serializable. have a look into this one. Is it serializable? Yes, it is serializable. So if I perform T1 first, then T2, then T3, then everything will be fine. I can clearly see that one because in T3, I'm simply writing and doing nothing, right? So whatever I perform T1 or T2 does not matter. If I perform T3 at the end, then everything will be fine, right? So this is definitely serializable. But if I draw the graph, we'll see that it is not complete serializable. Okay. I'll leave that to you to figure that one out. You definitely can draw the graph and figure that this one out. This is not complete serializable. Okay. Simple thing here, we can see that there is a conflict between these two. First perform 1 and then 2, and also in here from 2 to 1. So there will be a link from 1 to 2, and there will be a link from 2 to 1. So that simply means there will be a cycle. Since there is a cycle, that is not complete serializable, right? So serializable does not mean complete serializable, but if you figure out that something is complete serializable, that means that that is serializable. Okay. So you can try these two, but because of time, I will not go through here. But this is the same thing. I wanted to figure out whether this is complete serializable or not. Okay. Because of time, I'll move on. But hopefully you got the idea what you need to do. Okay. So if something is not conflict serializable, what are the problems that might arise? If something is not conflict serializable, then some problems might arise. What are those problems? What was the first assumption when we started isolation? The first assumption was everything will be fine. What if that assumption is wrong? We assumed that every transaction will finish. There will be no system crash, nothing will be there. What if that assumption is wrong? Right? So think about these two transactions, and at this point, after running all of this statement, at this point, there is a system crash. We were not able to run these two. Okay. Can you tell me which data item's value is wrong, A or B? At this point. If there is a system crashes in here, look closely, look closely. If system crashes in here, which data item is wrong? 3 people say B. Look closely, what will happen? Someone said A. It will be A. Someone saying both not commit. Is that the case? T2 is completely done. That means T2 is 100% successful. Have a look. In T2, we were able to perform everything. That means T2 was done. That means T2 is committed. With T1, we have issues. T1 is half done. What does that mean? That means T1 will roll back. If T1 rolled back, then something is wrong. How? Think about the value of A. Let me give you an example. That one will make sense. Let's say the value of A initially was 50. Okay. So if I read A from the database, I will get 50. Then I'm trying to update or write the value 100 in here. Now, after that, I read A. So I'm definitely going to get 100 because that is what I have written now. Then I am writing, that means I am trying to, let's say, add, I want to add 30 to this 100. So if I'm writing, then I'm going to write 130 and the rest of the thing will be there. When I roll back, definitely T1 will roll back. There is no confusion regarding that because T1 is not 100% complete. So T1 will definitely roll back. So T1 will go back to 50. Can you see that this 100 will not be there? So T1 will go back to 50, the value of A. So in A, the value is 50, but he read 100 and he performed all the operation based on 100. So he was supposed to add 30 to the value that is coming from T1. So now if you check, later you will see that in T1 you have 50, but in T2 you have 130. But he wanted to add 30 to A. Definitely A is wrong. What about B? Since T1 has not performed anything on B, B is unaffected with T1, but T2, whatever he wanted to perform on B, he was able to do that. Right? So he read B, he write B, everything is fine with B in terms of T2. We already know T1 has been aborted, so the effect of T1 will not be there. Hopefully that is making sense. So in this case, the issue is with A, not with B, because T1 was aborted, T2 was successful. Okay, if this sort of situation occurs, this is known as dirty read. Here the issue was reading was wrong. You read the wrong value, the uncommitted data. You read something which is not committed, right? Because we also have something in this transaction, so this data is not committed. If it is aborted, you will be in trouble, right? So uncommitted data, if we read that one, that is known as dirty read. What issue might happen in here? In the second scenario, in here, have a look. Here I am reading A, so let's say I'm getting 50. In here I am writing A, so let's say I'm writing to 100, and in there I am reading A again, and I'm getting 100. So just think about from the view of T1. T1 will see that I just read that item, that was 100. I just read that one again, and this is coming up as 100, from 50 to 100. Right? So T1 is seeing certain changes, although he has not performed anything, right? He has not done anything, but he is seeing here 50, here 100, right? So this one is known as unrepeated read. May not read the same value twice if we have some transaction who are writing the meantime. Someone is saying B is also not update with T1, so B is also the issue. No, in T1 we did not make any change before this system crash with B, right? So that's why everything is fine. Hopefully this part is making sense. Third error can happen is this: you are reading something in T2, you are reading, you are writing, and in T1 you are writing. Can you see the issue there? What is the issue that you have? So first you read the data, which was 50. In here you read, so you are going to get 50 as well. You are writing, so it will be 100. Now you are perform some write. Which value you are working on? 50, because that is the one that is we have read. You have not read that new value. So you are working on 50, but that is wrong, because the value has already been changed in intermediate state. So this one is known as lost update. Although we have made some update, but that is not reflected in here because we read the data before doing this, right? So why all of these issues are happening? Because they are non-conflict serializable schedule. Okay, so that simply means we will never run non-conflict serializable schedule. So whenever we have a schedule, we first figure whether it is conflict serializable or not. If it is not conflict serializable, we will not run them, because these three issues might occur. First one is known as dirty read. Second one is unrepeated read. We are reading the same value but getting different result. This one is known as lost update. Although we have made some changes, but since we are not reading, we are simply going to write, right? So we might work on the old value, not the new one. Someone is saying, does T2 not finished? I'm guessing in the first case you are asking. Yes, T2 is finished in the first case because there is no other statement on T2. Okay, so T2 had only these 4 and all of those are fine. Okay, hopefully making sense. Last part is, how do we ensure consistency using lock? Okay, so we figured out all the schedule. Now when we actually run them, how do we make sure that first we run T1 and then T2 and then something else? Okay, so there's where the idea of lock comes on. Someone already mentioned lock. So whenever we are trying to read something, we'll have a shared lock. Okay, we'll lock the item so that no one can interfere with me. when we are writing, okay, before writing, we will have an exclusive lock. Reading, two persons can read at the same time, right? Because that is, they are not conflicting. So that's why that lock is known as shared lock. Two person or two transaction can share that lock. Two person can read at the same time, that they are not conflicting. But when we have exclusive lock, right? So someone is trying to write and someone is trying to read, they are conflicting pair, right? So if someone is writing, we'll say that he needs to acquire a lock which is exclusive lock, meaning he will simply say that now I am writing, no one should do anything else. No one should try to write, no one should try to read. Okay, so that's what it means. Exclusive lock means data item can be accessed by only one transaction. Shared lock means it can be shared by transactions. Okay. Hopefully that thing is making sense once you understand conflict. If some transaction acquires some lock, they will release those locks only when the transaction complete. Remember that thing. This is sometimes confusing, or you make a mistake thinking that read is done. Okay, I release the lock. No, if you get a lock, you will hold that lock until the transaction is finished. Okay, does not matter whether you are performing that operation again and again or not. Okay, if you get a lock, you need to hold that lock till the transaction finishes. Okay, remember that, then we'll talk about it. Okay, first let's have a look, then we'll talk more. Let's say these are the two transactions I want to perform. So before reading, I need to get a shared lock. Before writing, I need to get an exclusive lock. That's what we write using X. Okay, so before reading, let's say we have started like this, that first we are doing T1, then we'll do something else. So we are trying to read. So before reading, we have to get a lock. S means shared on A, then WA, that means we need to get an exclusive lock. So we acquired a lock X, and then we are writing. Then what can we do? Can we think about, can we now perform start to perform T2? Can I run T2 now in here? There is no unlock option. Remember what I said? If you get a lock, you need to hold that lock till the transaction finishes. Unless the transaction is finished, the lock is in your disposal. Right? In this case, we cannot perform T2, definitely. Right? Why? Because if I am trying to read the data, I need to get a shared lock, but there is an exclusive lock. Someone is writing. I cannot do that. Right? So A is locked, must wait. Only option I have is I have to perform all the operations of T1. Right? Once T1 is done, that means the transaction finishes, then it will release all the lock. Then I can perform T2. Now we can see that we are performing T1 and then T2. We're ensuring the serial using this lock. Right? So once we start with T1, right, it will ensure that you can only work on T1. In this case, in different cases, there will be other scenario. Then only you can perform T2. Hopefully making sense. So this is the main thing to remember. If someone is holding a shared lock, someone is asking what does X means? X means exclusive lock. Okay. Exclusive locks is represented by X, shared locks is represented by S. Okay. If someone is holding a shared lock and someone is asking for a shared lock, so T1 is holding shared lock, T2 is requesting shared lock, that is okay. They can work. If T1 is holding exclusive lock, T1 is requesting for shared lock, no, he has to wait. In all the other three cases, he has to wait. Only shared is fine, but in all the other cases, we wait. Okay. Thinking about this one, can I perform it in this way? I have T1 and T2. Okay. So I perform something from T1, something from T2. Is it okay? Or is it wrong? This is definitely okay, right? Because I have a shared lock on A. In this case, I want to get a lock on B. So this is perfectly fine. There is no lock on B currently. So I can perform everything on A and then everything on B and then perform something else. Can I do something else now? I still have this part to complete. RB and WB. Can I do that one now in T1? Definitely no. Yep, we cannot do that. Okay, so we cannot run T1. Can we run T2? Someone is saying as soon as T2 releases B, T1 can lock B. But when does he release? Remember that. He only releases when the transaction is finished. In this case, the transaction is not finished. That means he will hold the lock. What about the same case? Can I run T1? Sorry, T2? Can I perform some operation on A? No? Yes. Yep, so you got the idea that if this is the case, then T1 is waiting on T2, T2 is waiting on T1. That means we are in deadlock situation. So both of them are stuck and cannot do anything in this case. Okay, so if you actually draw the graph and check everything, you will see that this is a non-conflict serializable schedule. Okay, it should not be allowed, and that is what we can achieve using locking. Okay, I don't have time to talk about how to prevent deadlock. I'll talk about this part next week. Okay, I only have 3 minutes before your tutorial starts. So this is it for today. Next week, I'll talk about how we can handle deadlock. Okay. From there, we'll talk about deadlock there. Okay, so deadlock simply means everything is stuck, no one is moving forward. Okay, so that's it for today. Someone is saying, why don't they release immediately? Yep, that is not the behavior of DBMS system. Okay, they only releases when the transaction is complete. Someone is saying, maybe declare all the locks at the start of the transactions, but it will only know when does it needs a lock, right? And what sort of lock he needs. Someone is saying in the last example, I'm guessing the previous one you were talking about, example 1. We can do T1 but not T2, or we cannot do all T1 and T2 due to deadlock. Oh, deadlock means this one. No, we cannot do anything. T1 must need to wait for T2. T2 needs to wait for T1 because T1 is holding a lock on A. T2 is holding a lock on B. If T2 works on A, that is not possible, right? If it is holding a lock on B, that is not possible.